Differentiate x squared y plus x squared y equals 10. All right, so yeah, we're used to functions where y is by itself, right? So in this case, we cannot get y by itself. Okay, can we still find the derivative of this guy? And the answer is yes, right? We use something called implicit differentiation, right? We assume, right, that y is just a function of x. Okay, so we're going to have to use a chain rule on this guy, right? Whenever we find a derivative of a term with respect to y, okay, we need to multiply. We need to find the derivative, right? And to multiply that by dy dx. Okay, remember, we don't know what. That's why it's called implicit differentiation, because we don't necessarily know what it is, right? But we just take the derivative with respect to x. Okay, so let's take a look. Now in this case, we're going to have to use a product rule as well. Okay, so remember what the product rule says. If we have something like f times g, right? The product rule says we have f prime g plus g prime of f. Now the key once again is whenever you take the derivative with respect to y, right, we need to multiply that by dy dx. Okay, so we're going to have to use the product rule on this guy and then product rule on this guy. Of course, the derivative of a constant, right? The derivative of 10 is just 0. So we're going to take the derivative of this whole thing. So, by the rules of differentiation, we can take the derivative of this guy plus the derivative of this guy equals the derivative of this guy. We can do these one by one. All right, let's do this step by step. What is the derivative of x squared y? Okay, by the product rule, right? So the derivative of that is 2x times y plus, right? Plus what? Is x squared times the derivative of y, which is just a 1, right? It's y to the first power. Okay, but then because we're taking the derivative of y here, we need to multiply that by dy dx. And then what's next? Well, what's the derivative of xy squared? Well, the derivative of x is also just 1, so 1 times y squared. But now plus the derivative of y squared is 2y, so we'll take the 2y here. But we took the derivative with respect to y, so we need to multiply this term by dy dx as well. And derivative of 10 is just 0. And notice that we are finding the derivative, right? There's a dy dx here. At this point, we need to collect all the terms with the dy dx on one side. So we're going to have to move these two guys over to the other side, right? So notice we get what? X squared dy dx plus 2xy dy dx. And then we'll just move these two on the other side, right? Negative y squared minus 2xy. Okay. Of course, the whole point of doing that is we can factor out the dy dx. We get x squared plus 2xy. And notice that eventually, or not eventually, the last step here, right, we're just going to divide this over. Right? Let's divide this over to the other side, so dy dx. In this case, our final answer is negative y squared minus 2xy. And all of this over x squared plus 2xy. And this is our derivative. We got this by implicit differentiation. Notice that our answer does have x's and y's in it, which is fine, right? Remember, if we graph this, right? Remember what the derivative does. It gives us the slope of a tangent line at a certain point. So if we can graph this, then at a certain point x comma y, right? Those are just numbers, right? So we can just plug those in, and that'll be the slope of the tangent line at any point, right, that is on this graph.